The spectra acquired using LIBSoft are background corrected. If a spectrometer is connected to the system and has been successfully detected and initialized by LIBSoft, the application will automatically acquire a new background spectrum once all the hardware components have been initialized. Thereafter, if any parameters that affect the background spectrum, for example the spectrometer integration time, are changed, then a new background spectrum is acquired automatically before subsequent analysis spectra are required. For the EMU spectrometer, the background spectrum is held in memory in Kestrel spec and is therefore neither displayed nor saved to file. For the Avantis spectrometers, the background spectrum is saved to file. The file name used for this spectrum is specified by parameters set in the acquisition configuration window. So if we open the acquisition configuration window, we can see the file name for the background spectrum is specified here, and the folder to which it's saved is specified here. It is also possible to initiate the acquisition of a new background spectrum manually using the appropriate shortcut button in the main screen toolbar. So this one here. So if we do that now, if a background spectrum is acquired manually, the user is warned if a background spectrum with the same name already exists, and is given the choice as to whether to overwrite it or just cancel the acquisition. In this case, we will overwrite the background spectrum. If the acquisition parameters have been changed and the acquisition of a new analysis spectrum is initiated, a new background spectrum is acquired automatically and the existing file is overwritten automatically. As an example, we will configure an acquisition typical of those used to acquire the spectra included in the test report and shipped with each system. Note that reproducing the spectra included in the test report is an excellent way of checking the performance of the system. So if we configure the acquisition, firstly the acquisition configuration parameters, we will set 50 conditioning shots, 50 accumulation shots, 1 spectrum, and just 1 measurement. And we've got a sample of copper, so we'll call this copper. And we've already set a folder for the acquired spectra. Now if we set the laser configuration, we'll use an acquisition rep rate of 5 Hz and a Q-switch delay of 150 microseconds, which for this laser equates to approximately 50 millijoules of energy. And then finally we'll configure the spectrometers. We'll set an integration delay of approximately 3 microseconds, and we'll change the integration time to 30 microseconds. Note that as we've changed the integration time, a new background spectrum will be automatically acquired when the acquisition is initiated. We can then initiate the acquisition using this button here, and we can see that a new background spectrum is acquired. Then the flash lamps are started. The conditioning shots are fired at the maximum repetition rate of the laser, followed by the acquisition shots at the rep rate set in the laser configuration. On completion of the acquisition, the acquired spectrum is saved to disk using the specified file name and displayed on the main screen. And the system status is returned to ready. Note that the laser flash lamp is not disabled automatically following the acquisition, leaving it ready for further acquisitions. It can, however, be disabled manually from the laser control and configuration window. The file name for the saved spectrum was specified on the acquisition configuration screen, so if we have a look at that, it was copper and it was going to be saved to this folder. But note also that the file increment option was enabled and it was initialized to 1. It's now incremented to 2 following the completion of that first spectrum. So if we open the folder where the data was saved, we can see the spectrum file here. The spectrum file is saved as a text file with the sample name followed by the file increment number in parentheses. In addition to the spectrum file, there is a parameter configuration file that's also saved, and this is a .cfg file. It has the same name as the spectrum file, but the file extension is different. This file records the parameters used for the acquisition of the spectrum. It's a simple text file and can be opened in most text editors, so we can open it with Notepad. And we can see that it contains all the parameters we set for the acquisition of that spectrum. The data in this configuration file can also be displayed using LIBSoft spectrum display and manipulation tools, and this is described in a separate video. If we now modify the acquisition configuration, and instead of having just one spectrum, we'll just set the number of spectra to 5. And then initiate the acquisition. As the parameters required for the background have not been changed, there's no new background acquisition. The conditioning shots are fired, followed by the acquisition shots. And you can see we have spectrum 1 of 5, because we specified 5 spectra to be acquired. And the second spectrum is acquired. And the third. The fourth. And finally the fifth. Spectra are saved and displayed. If we look at the displayed spectrum, we can see that the first of the 5 spectra just acquired is displayed, as denoted by this S1 suffix in the plot legend. However, a spectrum number control has now been displayed at the bottom of the spectrum window. And this can be used to select which of the 5 spectra just acquired to display, so we can cycle through them. And as we do so, the display is updated, so we can now see spectrum number 5 is displayed. If we look at the save files, we can see that just a single spectrum file has been saved using the same format as before, so sample name plus the file increment number, which is now 2, but with the addition of an S suffix. In LIBSoft, multi-spectrum acquisitions are saved in a single file, and the S suffix is added to indicate that the file contains multiple spectra. As with the single spectrum acquisition demonstrated previously, a configuration file is also saved detailing the parameters used for the acquisition. If we now modify the acquisition configuration again, and we'll reset the number of spectra to 1, but we'll increase the total number of measurements by setting both the points per line parameter and the number of lines parameter to 2. Now the total number of measurements has been increased to 4. So we should get a 2x2 raster pattern with each measurement comprising 50 sample conditioning shots followed by an acquisition of 50 accumulation shots. And we can then start this acquisition. The flash lamp was already running, so there was no need to start it. We get the first set of conditioning shots followed by the first set of acquisition shots. And note that when using an APL computer controlled sample chamber such as we have here, the sample is moved automatically between the specified measurement locations. If a manually controlled sample chamber or no sample chamber at all is used, the user will be prompted to move the sample between measurements. And if we just stop the flash lamp for a second and then move the sample a little bit, we can see that there is an array of 4 acquisition locations, and they're separated by the step interval, the X and Y step intervals specified in the stages configuration, which is just 0.5 millimeter. Let's close this for a second. And we can obviously zoom in on the sample a little bit to see the measurement locations more clearly. Looking at the spectrum display title bar and plot legend, an M suffix has now been added to the sample name. And this is to indicate that it's part of a measurement set. This is followed by the X and Y coordinates of the measurement location. The location of the first measurement is defined as x equals 0, y equals 0, and the other measurements are specified relative to that first one. If we look at the save files again, we can see that a spectrum file has been saved using the same format as before. So sample name, file increment number, but with the addition of the M suffix and the coordinates of each of the measurement locations. So 0, 0, 0, 0.5, 0.5, 0, 0.5, 0.5. Again, a configuration file is also saved detailing the parameters used for the acquisition. A single configuration file is saved as the parameters used were the same for all of the 4 measurements, and the file includes details of the number of measurements made. Note that if a manually controlled sample chamber or no sample chamber at all is used, but multiple measurements are specified, an integer will be added after the M suffix instead of the coordinates shown here, starting with 1 for the first measurement and incrementing by 1 for each subsequent measurement. Note also that if multiple measurements each comprising multiple spectra are specified, then the resulting spectrum files will include both the M suffix plus coordinates and the S suffix to indicate that each file contains multiple spectra. As before though, only one configuration file will be saved, as the same parameters were used to acquire all of the specified spectra.